Welcome to qnawire.
Okay, so I want to write a rational function, right? I want to write a rational function. A rational function is just a function that has a polynomial in the numerator and a polynomial in the denominator. I'm going to use a different color here. So I'm going to start with the x-intercepts. In a rational function, you find the x-intercepts at values that make the numerator equal 0. So in other words, if -3 is an x-intercept, then x plus 3 has to be a factor. And if +2 is an x-intercept, then x minus 2 has to be a factor. If 4 is an x-intercept, x minus 4 has to be a factor. That'll take care of my numerator. Vertical asymptotes are the values that make the denominator 0. So if x minus 2 or x equals -2 is going to make the denominator 0, I have to have an x plus 2 factor. If there's an asymptote at 0, that must mean x is a factor. And if 5 is a 0, 5 makes the denominator 0, then x minus 5 is a factor. Now, horizontal asymptote. To have a horizontal asymptote of 1, two things. The degree of the numerator must equal the degree of the denominator. Okay? And if that's true, then you have an asymptote at y equals the ratio of leading coefficients. So ours is pretty much set the way it is. I'm going to rewrite it down here. I'm going to use another color. So what we've got is x plus 3 on top times x minus 2 times x minus 4. All those values, right, that make our numerator 0 are x-intercepts. I'm going to just reorder this, put the x in front, x plus 2, x minus 5. Remember, those are coming from the vertical asymptotes. That's where I'm going to have 0 in my denominator. Now, the top of my function, I'll just jot over here, is degree 3. The bottom of my function is degree 3. So since I have the same degree on top and bottom, I'm good to go with my horizontal asymptote. If I want it at 1, I'm going to leave it just like this. I could also just put the same number on top as the bottom. In other words, I could put a coefficient of 4 and 4 here. Then I'd have 4 over 4, and that would also give me 1. That'll work. They're infinite numbers, but as it stands right here, this function satisfies all that criteria.